Okay. Okay, cool. Welcome back. First post midterm lecture. Cool. So we finished 2 out of 4 of our major topics now. So memory safety is all done. Cryptography is all done. And cryptography is all you're going to need for project 2. So all the lectures that you need to start project 2 are over with now. And we're going to start a new topic, which is web. So this is the 3rd of our 4 major topics. And so just like some of the previous ones where we gave you like an intro to cryptography lecture and an intro to memory safety vulnerabilities and C programming lecture, we're going to give you an intro speedrun to the web today. So if you're never going to take or have not been able to take CS161, which is the software engineering class here at Berkeley, like today is your speedrun of the entire CS169. There are certainly things that we're not going to cover because it's one day, but we'll give you everything you need to be able to start at least thinking about the most common attacks that people see on the web. So that's our plans for today. It's mostly a speedrun of a lot of web things, no real attacks today yet, but just laying the framework so that we can start talking about attacks starting on Wednesday. Okay, so that is the plan. Okay, so I guess just to get a bit, I don't know, philosophical and tell you a bit about how the web came to be. Well, it's really old. There's a lot of like, this is like old conceptual idea from World War II about how the web can be built. And I'm not going to talk about it in too much detail, but kind of the key takeaway from all this old stuff is that when the web was designed, it wasn't really designed with security. And so when people designed it, they were mostly focused about usability, and no one really thought from the beginning, how do I actually stop this from attackers? Like when this was first built, it was being used like in universities and stuff. So no one was really thinking about how to make the web secure. And so if you remember one of our very first security principles from like lecture 1, it was that you should always design with security in mind from the very start, because if you design something and then later it turns out that it becomes security sensitive, then you're going to have a really bad time going back and trying to plug in all the gaps, and your design is going to end up looking awkward. It's going to look complicated. And it would have been a lot nicer if it was designed with security from the start. So it turns out web is a good example of like what not to do, because this was something that was designed without security in mind. And so you're going to see today, there's a lot of really awkward attacks that are possible. And we have to use a lot of awkward defenses. And the reason why they're going to feel really awkward is because, well, the people who design web, they did not think about these things from the start. So it's kind of an example of what not to do. Okay, so yeah, web goes all the way back like many, many years, and there were these like conceptual ideas, but like ultimately all these words basically say that there's one way to think of the web, which is to think of it as like a collection of resources or like objects. And what's an object? It could be like a web page, it could be like a PDF that you want to load, it could be an image, a video. So somehow the web is just this big collection of data, and the data could be spread across all sorts of different computers. Like if you want to download a PDF, it could be from like the UC Berkeley servers or from like the CS161.org servers or from anywhere. So somehow the web has something to do with accessing all these resources that are distributed across all these different computers. We have to figure out a way to find where those resources are, how to access them. And so that's maybe the simplest possible way you can think of what the web is. Okay. And so a lot of what we'll be talking about is what we call, or I think what people call like Web 1.0, which is kind of the first idea of what the web could be. And it's kind of what I just said, which is that there's all these different resources lying around on the internet. Some of them are like just text documents, some of them are PDFs, some of them are images, and they're all lying across all these different computers. And your goal is to be able to pull them in and download them so that you can access files from other people's computers. So that's kind of like the 1.0 model of web. And it's kind of outdated. I mean, like, I would imagine the web has changed a lot since 2004, but it turns out that a lot of the vulnerabilities that still exist on the web, and we'll show you the leaderboard of like all the most common vulnerabilities, and a lot of the vulnerabilities that you'll see that relate to web, they still apply from the web 1.0 days. So the vulnerabilities that worked back then, they're still around today, and they're still regularly topping the leaderboard of the most common things. So if you're wondering, well, why are you teaching me this outdated version of web? Like, what about all the more modern developments? Like, are you going to show me React, which is a framework for building more modern websites? And it turns out that, yes, while those are also, those are modern ways to build websites, and they also have their own classes of vulnerabilities, the most common class of vulnerabilities is stuff that dates all the way back to Web 1.0. So the model of web that we'll be showing you, it's a little bit old, but it is sufficient to learn about all the vulnerabilities that exist, even in like modern web. So that's Web 1.0. Web 2.0, I think things got more reactive. So there was more interactivity. And Web 3.0, I think is just like crypto garbage. So I don't know about that. Okay. And we're not going to talk about that. Okay. So going back all the way to like introduction, what is the web? This is the model that we'll be using. It is admittedly a simplified model, but it is good enough to talk about the exploits that are the most common. So again, here's how I think of it, which is that the web is all these different resources spread across all sorts of different servers. So I could have the UC Berkeley server sitting somewhere in, I don't know, like the basement of Soto Hall, and that is serving files like PDFs, images, your homework to the rest of the world. And there could be other servers, like, I don't know, this server could be serving like, movies to the rest of the world. And so every server has some set of resources that is serving resources to the rest of the world. And how do you access it? Well, you go on your computer, you open your favorite internet browser, and then using your browser, you can connect and go access the resources from some servers. So you can go ask the server, hey, can you please give me, I don't know, please give me like this movie, or please give me my CS161 homework, and the server will send it back to you. And you're the browser. Okay, so that's roughly the model that we'll be going with. Again, it's kind of simplified, but it's good enough for our purposes. And so another question that people ask all the time is, what's the difference between the web and the internet? It seems like they're the same thing. At least when I talk about it to non-CS people, seems like everyone uses them interchangeably. So at least for this class, we're going to define web as the protocol that sends data between these two. So all I care about is that I am the browser and I want, I don't know, has anyone watched a good movie lately that we should use as a running example? Ferris Bueller's Day Off. Awesome. Okay. So like I want, Ferris Bueller's Day Off, totally legal copy.mp4, and I send it over to the server, and the server sends the copy back to me. So that process of sending information between the browser and the server, that is what we're going to consider the web. And then the process of, well, how does that information get from point A to point B? Like, how does that information get sent along this channel? Like, does the server send someone out with a USB drive and they give it to me? Do they send bits over like radio waves? How they send that information over to me, that's going to be the internet or the networking unit. So we're going to talk about the how of how information gets between these two people in the networking unit, which is the last unit of this class. But for now, we're just going to be concerned with how the data, or like what data goes between the two people, the browser and the server here. So we just care about what the data is, the protocol for sending the data, and specifically how the data gets sent. Like, do we send like a mailman to deliver it to you, whatever, that's going to come later. Okay. So that's our simplified model of what the web looks like. So we're going to give you a quick whirlwind tour. It's going to be really fast. We're going to cover these in not the most detail, but just enough for this class. So we're going to show you a lot of how the web works. It's going to be a lot of vocabulary. So fair warning, this is one of those lectures where just a lot of terms get thrown at you. But I don't know, maybe if you've like browsed the web before, which hopefully most of us have, some of these will seem familiar. So that's our goal for today, is to define a bunch of these terms. And then at the end, we can start talking about what the security model for the web looks like. Okay, so I will go one by one. So I'll start with URLs, hopefully a somewhat familiar term, but I'm going to break it down like all the way so that we can use it when we talk about security. So URL, it stands for something. I don't really care what it stands for, but what a URL is it is some string that uniquely tells me about one of those resources. So if you think of the web as a collection of resources, pictures, videos, files, and they're spread across all sorts of different computers, a URL is like one string that uniquely identifies a single item in this entire web of data. So that's conceptually what a URL is. Here's a URL, and again, maybe it looks familiar. So we're going to try and break it down and try to understand what all these pieces are. So the first piece, the way that you identify it is you look for the double slashes and you slice out whatever comes before. So those, the double slashes, I slice out what comes before. That thing is called the scheme. And we're going to see this in more detail when we talk about networking. But this scheme basically tells me, how do I transfer things from the browser to the server? And again, there are all sorts of different options. Like, do I use radio waves? Do I use cryptography when I send things from person A to person B? Do I like encrypt my data between person A and person B? Do I like, I don't know, send a mailman with like an envelope with a, I don't know, DVD and they send it to me? There's all sorts of different ways that information can get from point A to point B. And the scheme is going to specify some networking protocol, some set of rules that tells me how to do it. And so there's all sorts of different ways you can send information from point A to point B. We'll see a lot when we get to the networking unit. But all that you need to know for this unit is that there are two that we care about. So one of them is HTTP. That one sends information from point A to point B. And then there's HTTPS, which is a more recent version of HTTP that adds cryptography. So those are the two versions. HTTP, no cryptography, older version. HTTPS has cryptography added to it. But both of these are just ways to send information from person A to person B. There are all sorts of other ones that you don't have to know about. So for example, like SSH is another protocol for sending data. There's something called FTP that sends files that's kind of outdated. So there's all sorts of different protocols, but those are the two you have to know. So HTTP and its secure variant are all you have to know. Okay, that's the protocols, the stuff before the double slash. So we go onwards and we look for the thing after the double slash, but before the next slash. So there's the double slash, there's the slash after, there's all the stuff in between. So this is called the domain. And again, I know it's a lot of vocabulary, but this will help us talk about URLs in a language that we all speak. So the domain, I think of it as there are all these different computers serving data. Like there's a computer in the basement of UC Berkeley probably serving all sorts of data. And then there's probably some server in, I don't know, some like Netflix company server farm that's serving movies or whatever. And so all these different servers in the world, they're all serving different sets of data. And so this domain, it tells me which server to go to. Like, should I go to the server in the UC Berkeley basement and ask for a file? Or should I go to Netflix's, I don't know, like movie archive and ask for a file? So who do I go to ask for this file? That's what the domain is. So uniquely identifies a single server sitting somewhere in the world. Now, that's not like 100% true nowadays. You can add things like there could be mirrored servers and stuff like that. But for the purposes of the web unit, you can think of this as uniquely identifying a single server that's serving files. And again, not 100% true, but a good enough simplification for our model. Okay. So then we go onwards. And so I guess before we go onwards, you can also add extra stuff inside the domain. So sometimes people will also add a number in the domain. And so here we've added the number 4000. That's called a port, and we'll talk about it more probably in the networking unit. So don't worry too much about it for now. Basically, the idea of a port is like maybe that server has two applications running. So for example, that server in the UC Berkeley basement, maybe it's running two different web servers, and each of them is serving a different set of files. So the port number can help me decide, once I go to that server sitting in the basement, which application am I talking to? And the 4000 might help me uniquely identify one. So that's what the port is. Sometimes there's a username, but to be honest, I've never seen this before, and I don't think we'll ever see it in this class either. It's kind of obsolete at this point, but sometimes you'll see it. But the important one that you might see now and then is the port, and it's used if the computer or the server has two different servers running that are both serving different sets of data, and they're on the same server, and you have to identify one. Okay, so sometimes called the location, sometimes called the port. Again, it's a lot of vocabulary, but it's important so that we can talk about the web in the same way. Okay, then I look after the slash and I finally find all this stuff after the slash, and we call that the path. And so at this point, you know which server you're talking to. You've identified like, yes, I want a file from the UC Berkeley basement server that's like sending all these files or serving all these files to the world. And so once I've identified using the domain, which server I want to talk to, I have the scheme, which tells me how to talk to them. What language of internet do I use to talk to them? Do I use cryptography? Do I not use cryptography? Do I send a mailman to the basement of UC Berkeley, whatever? Once I decide the scheme, once I decide the servers, that's who I'm talking to and how I'm talking to, I can finally ask for a specific file. And so this path identifies a file on that specific server. So that's kind of how I think of it. And so, for example, you can imagine that maybe that server has its own file system, just like any of our computers have file systems. And so maybe that file system is also organized into like folders and subfolders and files. And so you can almost think of this path as, now that I've gone to this remote server, I'm going to go through that remote server's folders and request a specific file. So I could say, please go to this folder and get this file inside this folder on the remote computer, not on my computer, but on the remote computer that I'm talking to. Okay, that's one possible way to think about it. And again, modern web servers, they don't have to be organized this way. So they don't have to expose to you and say, yeah, you can get any folder you like on my computer. They could maybe select only certain folders to expose and serve to the world. These paths could correspond to all sorts of different things. So in the modern web, this is not 100% true, but if you're just getting the hang of what the parts of the URL are, you could say that this is the file path on the server. Okay. Uh-oh. Is the audio not working? That would be bad. Let me know if it's not working still, and I'll try to fix, but I don't know. We'll just have to hope the Wi-Fi holds. Okay. In the worst case, you can like call me and I'll talk to you over the phone. Okay. So there's also more things you can do. So we could serve files, and that could be the end of web. But as you know, there's all sorts of other things that websites do. So websites don't just serve static files to you all day. They're not just like, here's a PDF, here's a picture. Websites also do all sorts of other things. Like they can let you interact with it. Like, hey, click this button and something will happen. Or, click this button to buy something or to make a bank transaction. And so there's also more things you can do to websites, and the way that you might interact with websites to cause the website to do some computation or send you a web page that looks different depending on your input is you can also provide a query. And so this is going to trigger the server to do some computation based on the input that you provide. And this is how you can allow yourself to do more intelligent computation or talk to the server more intelligently than just, hey, give me a file, and you get the file back. Okay. Now, this is technically optional. And so you can totally just build a website that does nothing but serve files. And in fact, we at 161, we have a server whose entire job is just to serve exam PDFs to you. That server has nothing. It doesn't accept queries. All that it does is it just takes a PDF argument, gives it back to you. But for other websites, you could totally have queries. And so the way the syntax for it is you add a question mark, and everything after the question mark is the query. There's the question mark, everything after is the query. And you can almost think of these as like arguments. You can think of it as like sitting on the web server. It's like some function waiting to be run. And when you provide a query, you're asking the server, like, here are my arguments. Please run this function for me. So you could think of it as, and again, this is kind of a simplified model, just to repeat myself a couple of times, but you could think of it as this draw thing. It's not really a file sitting on this web server. So there's no file called draw sitting there, but maybe on the server, there is an endpoint, which is a fancy way of saying like a function called draw sitting on the server. And that server is waiting for anybody in the world to walk up to the server and call the draw function, and then maybe something will happen. So when I say /draw, I'm like, please don't give me a file. Please execute that draw function that you have sitting there. And don't just execute it with any arguments. Please execute it with this argument and this argument. So I'm providing name equals value pairs, where I'm saying that argument character, please set it equal to Evan, and the argument size, please set it equal to big. And I will pass this into the draw function, and then the server is going to run some computation perhaps, and then send me back the result. So that's one way of thinking of a query. And again, modern web servers, they can do whatever they want with the query. They don't have to run computation. But when you're first seeing a query for the first time, it's a nice way to think about what the query is. It's like passing arguments into a function that's sitting on someone else's computer. Okay, I guess really quick syntax note, we use ampersands to separate them. So now you know. Okay. So I think this might be the last part of a URL. I know there are a lot of parts, but this last part, it's separated by this pound symbol or hash sign. I guess you call it a pound symbol if you're old and you think like phone numbers, and you call it like a hash sign or hashtag if you're like, Zoomer, but I don't know. Okay, so the fragment, again, it's optional. You can totally have URLs that do not have a fragment. So whether you provide it or not, it could be a valid URL. But this thing is a little bit different in that this is not something that we send to the web server. So we're not like, go to the web server and do something with the fragment. Unlike all the other parts, right? Like this path goes to the web server. The query, it went to the web server. But the fragment is a little bit different. It stays within your web browser. And this is just to tell your own web browser something about the URL. And so one really common use of this is, have you ever like gone on Wikipedia and it's got like all those different sections, and when you click on a section, it just teleports you to the right section in the table of contents? Well, the way that Wikipedia does that, or any website does that, is it uses something called fragments. And so the fragment just tells me some property of the web page. For example, please skip to this certain part of the web page. And so that's one way to think about it. But overall, this is something that's happening on the client side. So it's happening entirely in the browser. The server has no idea that the fragment exists. The server doesn't care. It's entirely the browser's job to take this fragment and do something with it. And for example, one thing you could do is it could take the fragment and help you scroll down to the relevant section that you're looking for, or something else. The fragment could be used for anything. Okay. I think that's everything. Okay, one quick note, which is that maybe you noticed that there were a bunch of special characters. So there was like a question mark to start a query. There was a pound sign or a hash symbol to start a fragment. There were slashes to separate paths. So like, what if you wanted to use one of these special characters? Well, there is a way to do it in a URL. So the way to do it is to take your character. For example, suppose I really want to type a spacebar, but I can't put spacebars in URLs. So what do? I take the spacebar, I find the ASCII encoding of the spacebar, which happens to be the number 20, and then I add a percent in front. So %20 in hex or %20 in a URL, it's really going to be replaced with the spacebar for anyone who's interpreting this string as a URL. Or if I really want to use a literal hash sign, I don't want to start a fragment, but I want to introduce a literal hash sign. I would take the hash sign, I would go to my ASCII table, I'd look it up, I'd find out that the hash sign is 35, and then I'd stick a percent in front. Okay, and is everyone okay with what ASCII is? It's a table that maps characters to numbers. Okay, I think 61B talks about it. At least I heard Justin talk about it on like Friday, so I hope they talk about it. Okay, so that's URL escaping. It's kind of the same as how you'd escape things in, say, another language like Python or Java or C. But in URLs, the way that we escape is we take the character, write it in ASCII, so find the number corresponding to it, and then stick a percent in front. And if you want the percent symbol, percent followed by the ASCII for the percent symbol. That works too. Okay, so that's nice. One thing we're going to notice a couple weeks from now, so I'm not going to talk about it too much, but something we'll notice later is that URL escaping can make it hard to scan for a malicious URL. So suppose that you really don't want to see a URL that has this inside, because what does this mean? Maybe this means someone's going to your server and trying to dig out the passwords file. That would be bad. So maybe you're going to write some code to defend against that and say, if anyone comes up to me, I'm the server, if anyone comes up to me and requests the password file, I'm going to panic and say you can't do that. But what if instead of coming up to me with this, which I can read and I'm like, that's the password file, don't do that. They come up to me with something like this and I'm like, I can't read that. What does that mean? But it turns out if you decode every single one of those ASCII characters, it ends up being the password string anyway. So it can make things a little bit harder to read. It's called obfuscation. And we'll talk about it more when we get to intrusion detection. But just putting it out there that escaping is nice for usability, but attackers can use it for nefarious purposes too. Okay, cool. So I think that's all the URL trivia I have to give to you. Again, I know it's a lot of just info dumping and it's not the most interesting stuff, but it's important to know about it so that we can go on and talk about attacks. Okay, and again, here's another simplified like picture that I tried to draw. And again, most web servers, they don't work like this. A web server is not required to work like this, but it is a nice conceptual picture of what each part of the URL is going to do. So you could think of it as browser is talking to the server using the internet. There it is. That's always like before. And then what's sitting inside the server? Well, inside the server, I can have all sorts of files. Like I could have a pictures folder with files. I could have a secrets folder with a bunch of files that you're not supposed to access. And I could also have code sitting in the server. So in addition to files, I could have code. Like I could have the code of the draw function. I could have the code for a search function. And so the user can come and query not just for files, but also ask me to run certain commands or certain sequences of code. So if they come and ask me like, please give me pictures/evanbot.jpg, I'd go to my file system and fetch the file and give it back to them. If they ask me for the draw function, I would go call the draw function and the user can supply arguments using the name equals value thing. So bot equals Evan, size equals large. So that's one possible way to think about it. But again, just to make it really clear, not all web servers have to do this, but it's a nice simplified picture so that we can start thinking about attacks on web servers. Okay. Great. Let's talk about the next piece of vocabulary I have to tell you about, which is HTTP. So this is the protocol that the server and the browser use to communicate. So the reason why we need this, and maybe we'll have a slide on this. So this is a protocol, I guess not. So a protocol is a fancy way of saying that when two people talk, there needs to be a series of rules when we talk. For example, like when I'm talking at you, we can't just be talking over each other. There has to be a set of rules. Like for example, a set of rules might be like, if you have a question, you're going to raise your hand. And then what am I going to do? I'm going to call on you. And then you're going to ask your question. And then I'm going to repeat the question to the people in the Zoom chat. And then I'm going to answer it. Like those are the sequence of agreed upon rules. Otherwise, we would all just be talking over each other all the time and things would be really messy. So there has to be some sequence of rules. what the rules are doesn't really matter. Like instead of raising your hand, if you want to like stand up and do jumping jacks to ask the question, we could, as long as we agree on it. So somehow the protocol just has to be a series of rules that we agree upon so that our communication is clean. Otherwise, we're just going to be all talking at the same time and nothing will ever get done. Okay, so those are the protocols. We're going to see lots of protocols as we go into the networking unit, but this is your first one. It's called HTTP. So this is the set of rules that we're going to use so that the browser and the server can speak the same language. Because, well, browsers and servers, they don't really speak like English, right? I can't just walk up to the server and say, dear server, please give me the file evan.bat. Like the server's going to be like, what are you talking about? So somehow there has to be a series of rules and a series of syntaxes that I use or semantics that I use so that the server and the browser, they know how to talk to each other. And when you receive like an error message, both sides know how to interpret the error message, for example. So that's HTTP. We're going to show you how the protocol works. And remember, there's a variation of this called HTTPS that has more underlying security using cryptography, but we're not going to see that until the networking unit. So for now, you can just assume HTTPS is a version where attackers cannot read the data being sent over the channel or modify the data being sent over the channel, thanks to some cryptography magic. Okay, but the important thing about this protocol is that this protocol is something called request response, and which is a fancy way of saying that the server, not the server, sorry, the browser is going to make a single request to the server, and the server is going to send a single response. So this is a one-to-one thing. There's no such thing as I'm going to send 2 requests and get 1 response. There's no such thing as I'm going to send 1 request to get 2 response. All the data that I could ever possibly want from the server has to be bundled into a single request, which I push to the server, and then the server thinks about it a lot and then sends me a single response. And that's it. That just keeps things simple. And if you want to talk to the web server multiple times or you want to have a conversation, you can certainly send multiple requests. But ultimately, every single request comes with a single response. It's one-to-one. And that keeps things simple. Otherwise, we could just be sending all sorts of requests and getting all sorts of responses, delayed responses. It's just too complicated. So to make it simple, we're going to say there's 1 request going, 1 response coming back. That's it. Okay. So how do you make a request? This is where we have to define the semantics of what the request looks like. Because again, I can't just write a letter like, dear server, please give me, like the server doesn't know what that means. So we're going to have to come up with some syntax so that the server knows exactly what we're talking about. So specifically, we are going to break down an HTTP request into these pieces of data. So every single HTTP request is like a data structure. It contains these things. It has to contain a URL path. So that's the path in the URL. So if you go to your browser and I type like www.cs161.org/homework or whatever, then the path of that is /homework. So I'm going to put /homework in the HTTP request. And the browser knows how to do that. The browser will take your URL path, extract it, and put it in the HTTP request that it's building and it's about to send. Okay, so that's the path. It's from the URL. We've seen it. And then what comes next? Well, now I have to say, what do I want the server to do? And so here, there's a lot of different categories. And so you pick your favorite method, which is a fancy way of saying a category of what you want the server to do. And a lot of them are kind of obsolete or not really used these days. The two that are the most common by far are called get and post. And they have slightly different behavior, as we'll see. But the get request, that's usually used. And nowadays, there's lots of exceptions. But the original intention here was that there's kind of 2 main categories. So if your HTTP request is tagged as category get, then you're saying that you would like to receive data from the server. So all of the requests that are of the form like, dear server, please give me my homework PDF. Or like, dear Netflix, please give me this movie. Those are going to fall under get requests. Usually, not always, but usually. And then the second set of requests is called post. So any HTTP request of the category post, and again, there are exceptions, but in general, the intention of the post category is that these are the requests that are going to modify something on the server. For example, maybe there's a server out there and you're a user on that server. So there's like, I don't know, Facebook or whatever. Do people even still use Facebook? I don't know. But there's like a Facebook server and everyone has users. Everyone's a user on Facebook. And maybe you want to like change your password. So what are you going to do? You're going to send a post request and say, hey, Facebook, I know you're storing my username and password, hopefully a hash password. And I would like to change my password, please. So here's my new username. Here's my new password. Please change. And so I'm sending data to the server and I want the server to update something based on the data. Or I go up to Facebook and I say, oh, dear Facebook, I have a new picture I want to share. So I took a picture of my dog, I want to share it. So here you go, please post a picture for me. I'm sending data to the server and I'm expecting the server to change something about like its underlying database or something based on the data that I sent. So generally that's what the categories are. Get requests are for when I don't want to change something, I just want to get something like, hey, please give me all the posts from my friends in the last 24 hours, or please give me a PDF. And post is for when I want to send data to the server and I expect something to change. And so there are no hard and fast rules as to which one you have to use. The important thing is that we both agree. So as long as we agree with Facebook that all password change requests have to be post requests, then it's okay. When I send a post request asking to change the password, Facebook knows what I'm talking about. But maybe Facebook chooses to be weird and says, actually, if you want to change your password, please use the get category. They could do that as long as I'm consistent and I use the get request to change my password every time. That's okay too. It would be very weird, but technically it's okay. So there are no hard rules as to which of these two you have to use. In fact, in like the modern internet, these two sometimes get jumbled up sometimes, and you use one when you might have expected the other. But that's the original intention, is that get requests, they are used when you don't have to change server state. Post requests are when you do want to change. Okay. And so examples of when these two kind of get muddy are like when you want to download something, sometimes the server is going to change like its internal database. If it was trying to like spy on you or like trying to serve you ads or something creepy, maybe it'll like update analytics. Then yes, technically it's a GET request. You're like getting data, but you also cause the server to like track you somehow. So those are some examples of ways that these two kind of get muddy. But the original intention, GET versus POST, you pick one. You don't pick both. Okay. So what happens after you pick one or the other? Like, why do I even care that there's one or the other? Well, the important thing is that there is a part of the HTTP request called data. It's like a field in this like message that you're sending. There's a URL path field. There's a method field where you're like, you can almost think of it as like it's a form you're filling out. The URL path, you fill out the field. The method, you like check get or you check post. And so the reason why that matters is because if you check get and you're like, this is a get request that I am about to send off, then you don't get to put anything in the data box. The data box has to be blank. No one's going to look at it if you fill in data there. So if you choose to use get request, you have to leave the data field of your form blank. However, if you choose to check post and you're like, this request is a post, then you get to write data in the data field. And the reason why is because you're probably going to have to send some data so the server can modify its state. And to do that, you're now allowed to fill in the data field with whatever you want. So that's the distinction. If you check get, I'm like, I want this request to be of type get, then whoever receives it, they're not going to look at the data field. It should be blank. But if you choose post, you can put whatever you want in the data field, and whoever's at the end will look at it and process it in some way that you both agree on. Okay, so those are the three fields that really matter. There's a lot of fine print that doesn't totally matter. For example, a lot of browsers will attach something like, this is coming from, like, what kind of browser is this request coming from, what operating system, timestamp, the version of HTTP that you're using specifically, like 1.1, 1.2, 1.3, but those are kind of uninteresting. We're not going to test you on them at all. The important ones are path, type, get or post, and only if you choose post, then you're authorized to also throw in some extra data. Okay. Oh, and I guess final thing I'll note, I know it's kind of a wordy slide, but the path itself can also have query parameters. So another way to send data to the server, if you cannot put data in the data field, you can also pass the server arguments using query parameters. So both of those are valid ways to send information to the server. Okay, cool. I guess final thing I'll note is you can think about, if you go to your browser and you type something in the browser, you're like, www. I don't know, like wikipedia.org/something, I don't know, like potato or whatever. You really want to learn about history of potatoes. You're like wikipedia.org/potato. Well, what kind of request are you making there? Well, you're probably making a GET request. So intuitively, it makes sense that something like www.wikipedia.org/potato, hit enter, you expect to make a GET request. It makes sense because you're not asking to change the Wikipedia article. You're not asking the Wikipedia server to change anything based on your request. You're simply asking for the article on potatoes that Wikipedia has sitting there. So the fact that it's a GET request, it kind of makes sense. And the other reason why it makes sense is because you didn't supply any data. You supplied nothing but a URL path when you type the URL in your browser and you hit enter. So it kind of makes sense that when you do that, you're probably triggering a GET request. So if you ever go into your browser, you type something in the URL bar, you hit enter, you're almost certainly triggering a GET request because you didn't provide any data. and you're sending something to the server, hoping to get a web page back. So those are generally GET requests. Again, exceptions do exist out there. Usually that's a GET request. How do you make POST requests? That's usually when you're interacting with the website. So for example, if you want to change your password, you type in the website, you fill out the form, you click the submit button, that will probably trigger a POST request with the data that you filled in. Okay. Again, there are also other ways to do this. You can like write a piece of code that generates GET and POST requests, but those are the most common ways, at least in like daily internet browsing. Okay. I guess I should pause in my HTTP in our like discussion protocol and see if you have any questions. You raise your hand, do jumping jacks. Okay, yeah.
I was wondering about the like escaping of URL sequences. One thing, does the case matter, or they have to go characters?
Yeah, question is like, does URL case matter? That's an interesting question, right? Does it depend on the browser? I think in general it doesn't matter, but I would have to double check. It's one of those like URL trivia things that like even we don't care too much about, but it's a good question. Is URL case sensitive? I don't know. Maybe we'll find out later. Okay. Anyway, that was all the request. So that was how you bundle in all the data to send it over to the server in a way that the server understands. You fill out this really specific form with all these specific fields so that the server understands what you're sending. And then when the server sends you back a response, they also fill out like a form. So, you know, they print out their HTTP response form and they fill out all the fields in a very specific way. And then they send it back to you. And that way you have a response that's organized as opposed to just some random sequence of bytes that you have no idea what's going on. Okay. So what are they going to send back? Again, there's a bunch of uninteresting metadata like, hey, this is HTTP. We don't really care about that. But the important things, there's two. So one of them is they have to send back a status code. At the very top of their response, they need to return a number. This is at the very top of every HTTP response. You have to have a number. It's not optional. You have to have it. And the number is like a code telling you what happened with the request. So the most common code that you will never see is OK. And that just means that the request was successful and I'm sending back an actual response. So anytime you load something in your browser, you type wikipedia.org, blah, 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 you hit enter and you get a response. If you see the page, what probably happened is that you got an OK response with the header code 200, and then your browser showed the resulting page to you. But what if something broke? Well, if something breaks, there's all sorts of different error codes. Some of them are really common. Some of them are really obscure or obsolete at this point. And you don't have to memorize any of these, but maybe you've seen them lying around on the internet. So we all know our favorite, 404, which is the code for page not found. If you ever try to access something that's not found, you're like, who came up with 404? What does that even mean? 404 is the status code of the HTTP response that comes back at you. So instead of getting an actual web page, the data or the 404 is what tells you that I couldn't find the page. There's also other ones like 403 if you try to access something you're not supposed to. So if you go to like CS161.org/final exam solutions, like you're going to get a 403, you're not allowed to access that. It's also not on the website, so don't try. But that would be 403. There's all sorts of other ones. There's like a 300 something, which is redirect. There's all sorts of different ones. Okay. And then just like in the request, there's a field for data and you can fill it in. You can not fill it in. It's up to you. So like if the status code is okay, you might want to fill in the data with whatever the user requested. If it's a post request, maybe you don't want to fill in the data. You're like, okay, I updated your password. You don't need any data. It's really up to the server what it wants to return here. Like for a 404, maybe it doesn't want to return anything because it's a 404. What do you return? So it's up to you, but the server is allowed to put anything in here. The important thing is that every response has to come with a status code saying exactly what happened. Did it work? Did it error? If it did error, what kind of error happened? You have to be specific. And so that's the language that the server uses to speak with the browser. That way we know exactly what we're talking about. We have a protocol. Okay. Cool. That I think is it for HTTP. That's it for URLs. So anything else you want to know about them before we do more web vocabulary? Okay. More web vocabulary. So as we said before, the web, what is it? It's just a bunch of files sitting around on different computers, and you can request, and the computers will serve those files to you. But I don't know about you, like when I go on the internet, I usually don't just load nothing but like PDFs and images and just like blank text files. Maybe I go to like some old ass professor's website or just be like plain text. But modern websites, they tend to look better than just plain text. So, well, what's going on a modern website? How do modern websites look so nice? How do they have graphics and how do they have different fonts and stuff? And how can they be interactive? Like when I load, I don't know, like some online like flash game or something, how does the website know to interact with me and like give me interactive elements? How does it give me buttons to press and stuff like that? That's where these languages come in. These allow me to specify web pages that do much more fancy things than just serving me plain text or just a plain old image or plain old PDF. Okay. So we'll talk about each of these one by one. Again, we are only scratching the surface here. So you're not going to learn how to write HTML. You're basically just going to learn what HTML is. And that's kind of all we have time for in this class. But do know there's a whole world of interesting web dev stuff you can do in this space, just not stuff that we're going to do because it's not totally security relevant. Basically, what is HTML? It's a markup language, which is a fancy way of saying this is not for writing code, but this is for organizing your website and making it look nice. And it's going to allow you to create structured documents. So in the same way that Markdown is a markup language, so I don't know if anyone has used Markdown before, HTML also a markup language. Okay. If you have not used Markdown, it's totally okay. And so the way that HTML works, the way that you know that you're dealing with HTML is you see a bunch of tags. And so the way that HTML creates, I don't know, fancier looking websites is it uses tags. So if you do something like, do I have an example on the next page? I guess I do. Okay, so do I have any other ones? Okay, maybe not. So maybe if I do something like, I don't know, I want my text to be bold. So what do? I add the B tag to open and say everything after this is going to be bold. I write my text here. So there's my text, super interesting. And then when I'm done, I close the tag with the /B saying I'm done with bold. So no more bold after this, please. And you can do this for bolds, you can do it for italics, you can do all sorts of different things. There's all sorts of different ways you can make your website look prettier. You can use colors, like whatever you want. And so ones that we care about that are security relevant in this class, this is a small subspace, so there are all sorts of different HTML features out there. Some of them are vulnerable, some of them are not. But the ones that we're going to use, just so you're all aware, and when I like put one of these on the exam, you're not going to like complain at me. So there is one called A, and I don't know why it's called A still. Maybe someone will like look it up and tell me someday. But A is the HTML tag for links. I have no idea why. I've looked at the word link and I'm like, there's no A in there, but they called it A for some reason. That's okay. So the way that the syntax for it is, you open up with an A tag. There's the opening A tag. There's the closing A tag. And so what do you see? Everything inside those tags, all that text, it becomes hyperlinked, which is nice. And in these tags, you can also provide an argument. So I'm like, I don't want this to just be any link. I want it to be a specific link to this. And so that's what the href argument is for. It tells me exactly what the link should go to. So I use the tags to open and close where the link should be. And then the href tells me exactly where the link should go to. That's the HTML syntax. You don't have to memorize it, but it's good to have in your back pocket. Okay, or on your cheat sheet exam, for example. So there's the link. Go click on it after lecture's over if you want. Okay. There's also fancier things you can do. So suppose you want to make a form, like you want the users to fill out something, and you can do that too. And I'm not going to go through all of this. You don't have to memorize this. Go put it on your cheat sheet or something. But the form, you can, again, use a bunch of different tags. So for example, this tag right here, it's an input tag of type radio. So radio is like a little circle button you can click. And so that's probably going to generate like, this, for example, or I don't know, like this label over here. It's going to generate this button over here. Or if I want a button, then I'm going to do something like this. There's an input tag that's going to generate the button. The specifics are not too important, but basically the idea is that these tags allow me to have nicer looking websites like this. And I'd say the most important thing here in all this like jumble of syntax is that one more thing you can put in the form is you can specify what happens when a user clicks submit. So specifically here, when a user clicks submit, you are going to make a HTTP request to the feedback path. Remember, what do you need in an HTTP request? You need the URL path. It's specified right there using the action argument. And you need the type, which is specified right there using post. So inside this form tag, you can also specify something like when a user clicks submit, please make an HTTP post to the URL path feedback with the method post. And when someone clicks submit, hopefully that will happen. Okay. So you can also specify things like that if you want. And again, HTML, really big language, all sorts of different features, many of which we will simply never talk about. But yeah, if you click submit, you'll get a post request to that particular URL. And the contents of this form will be bundled as data, which is nice. Okay. So you can also do all sorts of other fun stuff. So that's a really nice desktop background. And so you can embed images. The syntax for images is a little bit weird. So HTML has all sorts of little syntactic quirks. One of them is that when you make an image, you don't do an opening and closing tag. You do a single tag. Like if you look at this line, there's an opening tag, there's a closing tag, and there's nothing else. And that tag, it has the name image, img for image tag, makes a lot of sense. And it takes in like an argument of sorts called src, which tells me where to find the image. And usually that's the URL, wherever the image is living. So here, the URL happens to be living there. And so if I say img src equals that, that'll feed me the image or make the image appear on the website. Okay. Sometimes it's called embedding, is a fancy way of saying making the image appear on the website, but that's what the image tag does. Okay. Great. And one thing I'll briefly notice that when you add this image tag, well, that also forces the browser to do one more thing. So when the server sends you this HTML, right? Like the server, what does the server do? It sends you an HTTP response. And in the HTTP response is a bunch of ones and zeros. And when the ones and zeros are decoded, it becomes this HTML. And what does the browser do? The browser doesn't just show you this raw HTML. That's ugly. So the browser actually has to take this HTML and make it look nice. And how is the browser going to make this HTML look nice? Well, one thing it has to do is it has to go find this image so it can show it to you. So a side effect of using this image tag is you are forcing anyone trying to show you this HTML and render it and make it look pretty to make another GET request to this PNG so that they can find that image, download it, and show it to you. So this image tag, not only does it make the image embed, but to do so, it has to force whoever is loading this HTML, like the browser, to make a second GET request. And you can imagine that we can use this for attacks. We can maybe trick people into making GET requests. But the important thing is that the image source, it embeds an image, and it's also possibly a sneaky way to get someone to execute a GET request. Because the only way to know what's hiding in that URL, like you and I both know that that URL probably holds an image, but the specific image that's there, like what actually is that image, the only way to know is to make a GET request and go download it. Okay, that's embedding an image. One more thing you can do is you can put websites inside websites. And so to do that, there's an argument called, or an HTML tag called iframe. That's what you use to frame websites inside another website. Just like the image tag, this takes in a source. And so the source tells you which website you're framing inside the other one. You can also specify height and width. So that's how big the embedded website will end up being. And so that's the syntax. I don't really know why, but the iframe, you have to close the tag. The ing one, you did not have to. I don't know. That's how HTML works. Okay. Sometimes people call the outer one the outer frame. The inner one's called the inner frame. So I guess the I stands for inner. Now you know, but not too important. Okay. So yeah, again, I realize I'm like kind of overloading your brain with a lot of HTML syntax, but you'll get a chance to play with this a lot in like project 3, which is the web project. And again, it's not stuff that you're expected to memorize. You can either just get familiar with it through practice, or if you feel like it, just dump it on your cheat sheet and call it a day. It's totally okay. Okay, but that's your quick speedrun of HTML. There's so much more we haven't talked about of what you can do with HTML, but those are some of the most common ones you'll see in this class, at least. Okay, so if you thought HTML was a whole world of pain, like get ready for CSS, which is an even bigger world of pain, but it's not one that we're going to talk about in this class. So you get one slide with 3 bullet points. CSS is how you make websites look nice. So if I just had, say, the HTML that you saw on the previous pages, all of my websites would look totally plain. There would be no style. There would be no background colors. There would be no text colors. There would be no fonts. There would be no styling of any sort, right? There'd be no, like, if you want to draw a little box around the text with a certain color, you want to make the submit button look pretty, there's nothing. Everything is default in plain HTML. And the way that you make things look nice is to use a language called CSS. And this is the language where you specify things like buttons should be blue, unless it's this type of button, in which case make it green. And when there's a text inside this class, please make it look like this. Or when there's a text that's wrapped in this tag, please make it green. Please make it, flash or something. So this is where you specify all the specific styling that you want on a website. And this is another world that's like even bigger than HTML. We can go so much into the details, but this is not a web development class, so we're not going to. But just know that that's what it's used for. And just like JavaScript, which is what we will be seeing soon, this is also vulnerable if it's used maliciously. There are all sorts of things you can do with it. You can force websites differently. You can even use it to possibly execute some code. So it's not good. Okay. It's not good if you're not careful, but it is good to make websites look nice. So that is CSS. Okay. you ever go into web dev, you'll probably write some CSS, but not in this class. Okay. And finally, this is what unlocks all of the interactivity on a modern website. It's JavaScript. This is the language, programming language that is, that all of our browsers run in order to do things that are not just showing you a static web page. So if you ever load a website that's like letting you play a game or something, JavaScript is most likely what's unlocking it. Or if I like open a website, show you, I don't know, like a demo or something, I click some buttons and something happens, JavaScript is probably what's making all that work. Or like, even if I open Google Slides, like how is Google Slides showing me all these slides, making the animations appear? Probably some fancy JavaScript. I guess I'll never know. But this is a programming language for running code in the browser. And I'd say the most important thing, like if all these definitions have put you right to sleep, I understand. But the most important thing that you should take away is that JavaScript is client side. That is a fancy way of saying that the JavaScript is executed by the browser, not by the server. This is a really key distinction because it might be tempting to think, well, if I want to play a game on my browser, isn't it the server that's doing all the work of like computing the logic and like telling me like, where the little character is moving? Well, that's not quite true on the web. So instead, the way that I think of it is I go to the server and I'm like, server, please give me your browser game. And what does the server do? The server does not actually execute any code at all, or it doesn't have to. The server is just going to go dig up its relevant pile of JavaScript and send all of it to you. It'd be like, here, you run this, you browser, you give the user the game. Like, I'm not going to deal with that. And so this is how JavaScript works. It runs on the browser or the client side. The server has no responsibility but to take that pile of JavaScript code and dump it on the browser, send it using HTTP back to the browser. And then it is the browser's job, like your computer is the one that's running that JavaScript line by line, or your browser is the one running that JavaScript line by line to make the website look nice. It's not the job of the server. It's entirely within your browser that's doing it. Again, sometimes exceptions exist, but for the most part, JavaScript is a client-side language. Okay. So again, if everything else is just boring old definitions, JavaScript being client-side is going to be really important for the attacks that we do, because it's important to know who is executing that code. Is the browser executing it? Is the server executing it? That is an important distinction that we're going to see. Okay. And what can you do with JavaScript? You can kind of do whatever you want. Like JavaScript's a really powerful language. It can compute things, like it can do math operations. It can make the website interactive. So like if you click this button, this happens. If you click this button, this happens. You can make the website like messages can pop up. You can have like characters going all over the place. You can kind of do anything you want with JavaScript. There's all sorts of different things you can do. So we'll show you just a very small subset of examples, but do know it's a very powerful language. And if you want to use JavaScript with HTML, and that's this point right here, the way that you do it is you wrap the JavaScript in a script tag. So in the same way that you can use an A tag to get a link, you can use like the B tag to get bold, you can use the script tag to put JavaScript inside HTML. So I can write an HTML document and then have a script inside and the script will execute. Okay. And again, this is not like a JavaScript class, so I'm not going to ask you to write like tons of complicated JavaScript. You will write some one-liners in the same way that in project one, you wrote some one-liners for C, but we're not going to ask you to code like complicated stuff in JavaScript, but it's a nice language to know, I'd say, especially if you go into web development, because it's so common. Okay, but not something you have to memorize. This is a really long slide that I'm not going to read. But basically, one thing that is kind of important, but not for you, but if you ever go work at, say, like Firefox or Mozilla or whatever, or if you ever go work for like Google Chrome, then it's going to be really important that the browser itself is secure and not memory unsafe. And so why is that? Because think about what your browser is doing. Your browser is downloading JavaScript from every corner of the internet. Like, who knows what the user is going to request? The user could go to like malicious websites. The user could like get JavaScript from all sorts of attackers. And what's that going to do? The browser is going to have to take that code from the attackers or whatever and run it on the computer here, right? It's client-side code. And so if you're the person implementing a browser, like it's not me, but if it's ever you, if you ever go work for Firefox or something, then you're going to have to be really careful and make sure that the browser itself is not vulnerable. Because if your browser has a memory safety vulnerability, then the attacker could write JavaScript. The user could download the JavaScript, run the JavaScript on their computer, and that could break other parts of their computer. So it's really important that modern browsers, they're like carefully sandboxed, they're memory safe. So even if the attacker gives you a bunch of malicious JavaScript, hopefully it doesn't like destroy your computer. It could certainly cause funny things to happen, but it shouldn't like destroy your computer. Okay, so I guess a bit of a tangent, but good to know. Okay, so what can JavaScript do? JavaScript, and again, the syntax is not important, but the JavaScript can like modify a web page. So one thing you could do is if I run this line of code, suddenly you change where the link points to, that could happen. Or so now the link, if you click on it after running the JavaScript, it takes you somewhere else maliciously, possibly. You can make a pop-up message. So the alert function is one that you'll see all the time. I think of it as almost like the hello world of JavaScript. So if you're ever not sure if the JavaScript is executing, you run the alert function, and what does it do? It gives you a big flashing pop-up, and you know for sure that the alert has actually happened. So that's one possibility. There's also all sorts of other things you can do. One thing you can do, and you'll be doing in project 3, not 2, but 3, is JavaScript can also make requests. So JavaScript can say, please make a post request to this website with this data. JavaScript can do that too. It can make GET requests. It can make post requests. And it can even try to use this to leak secrets, for example. So you have to be careful. Okay. I think that is mostly it for JavaScript. Again, not a JavaScript class, but language that you'll be seeing a lot, at least when we talk about attacks. Okay, so as we said, all of this happens client-side. Like this is the key of the web, is that it's all happening client-side. All that the server does in most cases, not all, but most cases, is the server just goes through its list of HTML or JavaScript files. It just digs up the raw JavaScript and dumps it on the browser and says, here, you make it look pretty for the user. I'm not going to do it. So the server is not actually sending you, a fully rendered nice web page. Server is just sending you HTML and JavaScript code, and it is your web browser's job to make it look nice. And so the exact process is not something we're going to talk about in too much detail, but basically they have to take the HTML, they have to parse it into a nice format, they have to run all the JavaScript, and only then do you get a nice, pretty looking website. And all of that happens browser side. The server just sends you a pile of scripts, and your browser has to make it look nice and actually draw the picture on your screen. Okay, so sometimes people call that rendering. If you ever see document object model, it's a fancy way of saying that's how the HTML is parsed. But the important thing is that everything is browser side. Server is not sending you like a picture of what the website looks like. The server is sending you the actual HTML, and your browser is the one making it look nice. Okay. Okay. So again, I realize I kind of overloaded your brain with a lot of just security or not security trivia. So in the last 20 minutes, I'll talk to you about security on the web, or at least giving you a rough overview of what the threat model is like. Anything you want to know about web trivia before that? I'll try my best to answer. Again, a lot of it is just like random vocabulary and facts, but it's important. It's boring, but it's important. Okay, let's talk about threat models. So I have absolutely no idea why the first risk is number 2. That was unexpected, but I don't know. We're all friends here, right? I'm gonna go look into this, and you'll have to forgive me. Okay, that's number 2. That's number 1, and that's number 3. Okay, that's clearly out of order, so I'm gonna move this one down. I don't know why. Okay, that's number 1. I actually don't know why they're in this order either, so I guess we will find out. All right. So let's talk about what could go wrong with the web. So we know the system now. We know that users communicate with servers, the servers send the files, and the user executes HTML or JavaScript based on the files that are sent back. So we know how it works. Now let's think about what could possibly go wrong. So here's one thing that could go wrong, which is people could hack into those web servers. So for example, say you have that server in the basement of UC Berkeley, and it's serving homework or exams or whatever to the rest of the world. Well, imagine if someone went inside and broke into that server. Now they have total control over that server, so they could modify the server. They could say that exam file, make it public, or like that homework file, change it, make it say something else. So if someone hacks into one of these servers, then when you talk to that server, you are now talking to the attacker. Or if you request the file from that server, you could get malicious files back or malicious code back. And you can imagine this could be even worse if someone hacks into the google.com servers. Now, when you go to the google.com server and you ask for something, or you're please run the search function, they could return all sorts of garbage. It's up to them because they control the server. And so this is a risk on the web, right? In the web model, this is a possible attack that we have to think about. But the ways that you protect against it, they're not really like web attacks necessarily. These are the same attacks you would use to make any server secure, not just a server that's connected to the web. So any defenses that you would use to make a normal server secure are the same defenses you'd use here to make the web server secure. So it's mostly stuff you would expect, like, make sure it's not using a memory safe language, install antivirus if that's something you're worried about. So it's kind of the general industrial strength tools we would use to make a server secure. And we'll talk about those more in the networking unit and at the very end of the class as well. But this is a risk. It's not one that we're going to talk about too much because it's not key to the web protocol. But do know that if you wanted to, you can make a threat model where you said, yeah, maybe someone did hack into google.com and now I cannot trust anything coming from google.com. That's a possible risk. So it's not one we're going to include in our threat model, but it is a risk. So there it is. It's number one. Okay. In no particular order. Okay. Risk number two, this is one that we already kind of talked about, which is that imagine if you went to some evil website, and why you went to this is, beyond the scope of this slide. So maybe you just decided for fun, you were going to go to evil.com and see what happens. Maybe an attacker tricked you into opening evil.com, like you clicked on the link without knowing it went to evil.com. And we'll talk about that kind of attack too. Maybe an attacker walked up to your computer and typed in evil.com. I don't know, but somehow you have loaded an evil website. And so things can go wrong now because the attacker, what can they do? They can serve you anything they want. They can serve you a malicious PDF with bad images on it or something. Or they could send you, I don't know, but even worse, right? They could send you code because what do we know about the web? The code runs on the browser side. So yes, they can certainly send you all sorts of like naughty images or whatever. Or the evil.com website could send you JavaScript and HTML and CSS. And what does your browser have to do? Your browser has to piece together that HTML, CSS, and JavaScript and load a nice looking website. And in the process, your computer now has to run any old code that the attacker supplies to you. So in fact, what happens when you visit an attacker's website is you're giving the attacker full control. You're letting them execute any code that they want on your computer. They could execute a line of code like, please access the user's passwords, or please install this malicious software on the user's computer. That is what could happen, and it could be really, really bad. And so the modern industrial strength defense against this is that you have to make sure that your browsers are properly access controlled, something called sandboxing. And so here the idea is that yes, the JavaScript, you're going to have to execute it no matter what. Because the browser doesn't know whether you intentionally visited evil.com or not. The browser has no idea what this website is. And so when the browser receives the code, it's going to have to execute it no matter what. But at least we can minimize the damage by making sure that that code cannot touch things outside of the browser. So for example, that JavaScript, if it tries to access files on the computer, the browser will say, no, you can't do that. Or if that code tries to, I don't know, like destroy the entire computer's operating system, the browser is going to say, no, you cannot access things outside of this browser. So this requires the browsers themselves to be written correctly. And again, if you're ever someone who works on Firefox or something, then you're going to have to make sure you're being really careful in writing your browser securely. I'm assuming that's not like most of us, like we're not the ones implementing Firefox. So we have to rely on them to make sure that the browsers are secure. And this relies on a bunch of security principles we've talked about. We want to make sure that the JavaScript that runs from the attacker, it has least privilege. It should not have access to destroy my computer. It should only have access to the stuff within the browser so it can show me something or show me the result of whatever that web page is. So this is also a risk, but it's also a risk that we're not going to be talking about too much because the person whose job it is to defend against this, it's the browser's job to implement a good sandbox and make sure that the malicious JavaScript that comes back, if it doesn't do too much damage. It's probably going to do some damage, like maybe it starts like, flashing things or whatever, but, hopefully it doesn't do too much damage. That's our goal. Okay. And so risk 3, this is finally the one that we're going to talk about. This one is web security relevant, finally, is that imagine if you load maybe 2 websites. Maybe you have 2 tabs open, and in one tab, you go to your super legit bank website. You're like on bank.com and you're doing your banking. And then on the other website or on the other tab, you open up like evil.com. Who knows why? Maybe by accident or something. But now you have 2 different tabs open. You have evil.com and you have bank.com. And both of them are open in the same browser. And well, what do we know about both of these websites? When you load them, they are allowed to give you any JavaScript that they can possibly think of, and your browser has no choice but to execute that JavaScript and render those web pages. The JavaScript has to be executed to render the web pages. So when the bank.com and the evil.com websites send back JavaScript, we are forced to execute that stuff. We have no choice because we have to render the web page for the user as the browser. But there is one possible risk here, which is, well, imagine if that bank.com web, or if that evil.com website, it had some JavaScript that was like, hey, go to that other tab and like peek at the user's bank.com tab and like check out what they're doing over there. Like check out their login information, or please go check out how much money they have in their account. So the evil.com website, they might be tempted to write JavaScript that peeks at other resources that they're not supposed to. For example, this could be things that are living in the other tab, or they could be peeking at like, hey, can you, I don't know, download this thing from bank.com, or like, can you post something and log in as the user? And so this evil.com website, it might be tempted to load resources that it's not supposed to, or try to access resources that it's not supposed to because it's from a different website. And this is one of those things that if web was designed from the start with security, this would not be a problem. They would have figured out a policy to separate out websites so that the evil.com website can't use JavaScript to read or write things from bank.com because that's bad. But they did not do this. They did not think about it. So we had to add something after the web was designed. So this is the same origin policy. It's going to feel weird, I promise. However, the reason why it's going to feel so weird is because they did not design this from the start. This is something that we grafted on top of web after it was fully designed, just for the security, and that's why it feels kind of awkward. But awkward or not, this is what we've got. So here's the same origin policy. The goal is we want to prevent what we just said, which is that if you have two websites in your browser, or if you have one website and it's trying to access another website, somehow these websites should not be able to talk to each other or interact with each other. So if you load a bunch of JavaScript from evil.com, that JavaScript should not be able to talk to another website, should not be able to write things to the facebook.com or bank.com server, should not be able to load things from the facebook.com or bank.com server, should not be able to like peek at another tab and see what's going on. We don't like those. We want to stop those. So the same origin policy is our best guess to help us stop websites from interacting with other websites. And so this word unrelated, like it's so vague. And so we have to define what it means for two websites to be related and unrelated. And again, if the web was properly designed, maybe they would have come up with something cleaner, but it wasn't. And so instead, we have to take our best guess as to what it means for websites to be unrelated. Is it going to be fully correct? I don't know, but it's the best we can do. Okay. And whose job is it to enforce the same origin policy? Remember, where's all this stuff running, like the JavaScript that comes in and the HTML that comes in? All of this is stuff on the browser. So it is the browser's job to make sure that the JavaScript that it's running cannot access other origins. So all of this is browser side. All the things we're going to be talking about, at least for today, it's all browser side. Okay, so that's the same origin policy. That's what it's supposed to do. And so here are the rules. And if you're like, wait, these rules don't totally make sense, well, maybe not, but it's what we've got. Okay, so the rules are actually not that bad. And so the way that you're going to do this is you're going to take your best guess as to the origin of this website. In other words, like you're going to take your best guess to see if two websites are related or unrelated. And the way that you're going to do it is if you have two different URLs or two different resources, you're going to identify the resources with their URL, and you're going to extract three pieces of information. Look, they're even color-coded. The three pieces of information you're going to extract are the protocol, that's this string over here, domain, it's another string, and port, which is a number. That's it. Those are the only three things you extract. Everything else, like the path, the query, the fragment, you leave behind. We're not going to use those to check if websites are unrelated. They're still important. If you want to access a website, the query still matters for sure. But when we're checking if two different URLs or two different resources identified by a URL are, or by two different URLs, when we want to check whether those two different URLs are related in some way, we're just going to extract these three pieces of information and only these three to check if they're related or not. Okay. And this is just a piece of trivia, which is that if you don't specify the number, you don't specify the port, it's usually default 80. And the reason why is because that's what HTTP uses. Okay. So how do you check? Well, it turns out it's basically string matching. So it's not going to be the most interesting thing, but all you have to do is you have to take those 3 pieces of information that you extracted from a URL A, and then take the 3 pieces of information that you extracted from URL B, and you simply check the strings one by one. And if they all match exactly, then you have a domain match, and you assume that these 2 URLs are related in some way. And if any of the strings don't match, then you assume that they are different in some way, and that's it. So what do these URLs represent? They uniquely identify something on the web. It could be an HTML page, it could be a PDF, it could be an image. And if we have 2 different URLs representing 2 different things on the web, the way that we tell if those 2 resources, whether they're JavaScript or images or whatever, the way that we tell whether or not they are related in some way is we use the same origin policy, and we check these 3 and only these 3 strings. And so here's some examples. And again, think string matching. Don't do anything fancy. All we have to do is extract things and check if they match. Okay, so here are some examples of extracting the domain and seeing if they match. Remember, all 3 have to match, not just one. But here I'm just extracting the domain to show you. So what do? I extract the domain. Well, one of them says HTTP, one of them says HTTPS. And again, don't overthink, right? Just do basic string matching. HTTP and HTTPS, are they the same string? No. So are they the same origin? I can stop right there and say these 2 are not related. Okay. So I pulled out the domain of the URL, and I found that they are different. So these 2, whatever resource these 2 URLs are referring to on the internet, whatever resources they are, I'm going to assume they're not related. And you might look at this and be like, oh, but wait, they have to be related. Like they're the same URL, there's only a little difference. How could they not be related? But remember, the same origin policy does not care. It just extracts 2 URLs and answers yes, the strings are the same, or no, the strings that I extracted are different. That's it. That's their rule for deciding if things are related. And it is the best that we could do when we grafted this on top of web at the end. Okay, here's another one. So again, we look at the left, we look at the right, and we compare the protocols first. So HTTP, do the strings match? Yes. So I go on, I check the domains. I extract this domain, I extract this domain. Do they match? String matching says no. So I say this doesn't match, not the same origin. And again, you might be like, but wait, like, aren't these both owned by the CS161 domain? Like, aren't they both somehow related to CS161? How are they not related? Same origin policy does not care. It just looks at the strings, and if the strings don't match, it reports false and says these 2 resources are not allowed to communicate with each other. So the website on the left has JavaScript and the website on the right has JavaScript. They are not allowed to access each other's resources. Okay. And final one, which is, okay, I'll pull up both of them. Okay, so domains, yes. HTTP, the same string. The domain, I pull that out. That's a really ugly circle. And I pull this out. Are they the same, doing nothing but string matching? Yes. Then I pull out the port. That's the number 80. That's the number 8000. Are the numbers 80 and 8000 equal? No. For like all values of 80, they're not equal to 8000. So this one we say it's a port mismatch. So you get the idea. It's nothing but string matching. And again, even if you're tempted to say, but wait, like they're probably related, and you might be right, but same origin policy doesn't know. The best that it can do to balance security and usability is to just check these strings. Okay, that's same origin policy. It is simply checking strings. And so what happens now is that, sorry, I'll pull up some words. Okay, so what happens now is that if you have 2 resources that do not have the same origin, for example, CS161.org, there's some resource living here. It's probably some like HTML with some JavaScript. Like that's what is living at CS161.org. That's the resource identified by this URL. I know I kind of truncated it, but it was out of space. And there's also another resource on the internet, google.com. And if I type this into my browser, I will find another resource with like HTML and JavaScript. And so the idea is that these 2 resources, because they have different origins, they cannot interact with each other. And so this manifests or appears in all sorts of different ways. So for example, if you embedded one of these within the other, they would not be able to talk to each other or communicate with each other because they have different origins. So if I was CS161.org and I embedded or added a little iframe with the google.com website inside, I could not change how the google.com website looks or behaves because we have different origins. I cannot go and affect how a different origin looks in the browser. In the same way that I can't go and like change how a different tab works if they're different origins, I can't go into google.com and change how it looks. Okay. And there are some minor exceptions. I'm not going to run through them in too much detail because honestly, they're kind of like trivia, but I guess I'll quickly run through them. So one thing you can do is you can fetch JavaScript from an external origin. And so, for example, if you go to the CS161.org page, you're going to get a pile of HTML back and JavaScript back. And you might get something like this, which is kind of weird syntax. I don't think we've seen it yet, but you might get something like this, where you're like, I don't know, you might get script with a source tag. And like, what is this? Well, what this says is like, please go, excuse the handwriting. It says, please go to this URL, download the JavaScript that you find at this URL, and introduce this URL onto the CS161.org website. And that is one of the exceptions that's okay. So under regular same origin policy, what would you say? You'd say, no, because my origin is 161.org, their origin is google.com, these cannot interact. But for JavaScript that's fetched from an external origin, we do allow it. And so we say that JavaScript gets copy pasted onto our website, and it now has the origin of CS161.org. So that is one of the allowed exceptions, which is when you're fetching JavaScript from external resources. Turns out this happens pretty often in real life. Like instead of you writing all the JavaScript yourself, you might want to go like import JavaScript from someone else. And if you want to do that, same origin policy says that's okay. You can read that JavaScript from someone else and you can use it yourself. And from now on, that JavaScript on your webpage, like it belongs to you. Okay, that's one of the exceptions. Another exception is that you can fetch images from other origins. So you could say something like, we've already seen the image source tags. So if on like 161.org, I really want to embed the image of the potato. So there it is, potato.jpg. If I really want to embed the image on CS161.org, I am allowed to do so. It's an exception to the same origin policy. So in normal same origin policy, I'd say, no, this is CS161.org. That's wikipedia.org/potato, and they're not the same origin. I'm not going to let you take that image and pull it over, but or like embed it on your website. But here, we're going to allow it. You can embed the image, but there are some restrictions. For example, you can't change how the image looks. You have to embed the image exactly as is. You can know about things like how large the image is, the dimensions, but like it's limited, right? You can't just go download the image and do whatever the heck you want with it. The amount of things you can do with it, it's limited. Okay. And beyond the scope of this class, but there are also ways to talk to websites of different origins. But again, it's limited. You cannot just use JavaScript to go to bank.com and do whatever the heck you want. It's limited. You have to use some protocols called like post message. And it's a limited, very narrow scoped set of things you can do to communicate with someone else. So that's called cross-origin resource sharing. It's a fancy way of saying two websites with different origins, they could share and communicate resources with each other, but only in a very limited way. You have to explicitly allow it and say, I am overriding the security policy to allow these two resources to talk to each other. Okay, so that's the same origin policy. It's got a couple of small exceptions, but overall, the key here is just that I want websites with different origins to not talk to each other. Okay, questions?
Would it be easier to just not have a website with no origin talk to each other? Like not at all?
Yeah, there's a question of like, what if I just want to completely forbid this? I mean, yeah, you totally could, and that's one option. But remember, we have to balance like web and or security and usability. So if I want to just delete cross-origin sharing entirely, I might lose some. There might be some websites that no longer can communicate when maybe they wanted to or should. So as an example, this one, these two have different origins, but like, if we look at them using our intuition, maybe they're both owned by the same organization. And maybe they do want to share some resources and talk to each other, but they cannot do so under same origin policy. They'd have to use cross-origin resource sharing to do it. Or maybe like maps.google.com and images.google.com. Maybe they want to share something or share some resources under same origin policy. Same origin policy would strongly believe like maps.google and images.google are different people. But we kind of know they're probably the same, mega corporation conglomerate. And so, okay, if you use cross-origin resource sharing, now those two websites can talk to each other. Great question. Okay, any other great questions? Anything on Zoom? Did I crash? There's a question of, can the browser not run the JavaScript? I'd say that depends on your browser. So maybe you have some like browser extension or something that stops you from running JavaScript. But in general, if the user requests a website and the website has JavaScript, like a natural browser thing to do would be to execute the JavaScript. Okay. Question about, does iframe inherently cause a cross-origin resource sharing error? I think iframes are allowed in that you can embed, but you cannot modify what's inside. So that's the origin rule. And again, same origin policy has all these little nitpicks. Most of them for our class is not going to be too important, but they do exist. Okay. Final question. Also, if people need to like go, you can go quietly pack up, but I'll take a question. Yeah.
There's no way for like, for me to over the server, $161.
Is there a question like, can you register a server called 161.org? So we'll talk about this when we get to networking. When we talk about networking, there is a protocol for like who even allocates like the 161.org domain. But for now, we're just going to assume all these exist and that we can access them. That's a great question though. And when we talk about DNS, domain name server, we'll talk about how those exist. Okay. As you like slowly file out, I know it's 6:30. I will at least tell the recording people like a brief summary so you can have it for reference. So today was a lot of vocabulary, a lot of syntax, but we talked about URLs. We broke down the paths. Oh, someone's scribbling. Okay. So we talked about URLs. We talked about how you can break it down into all these separate parts. And we use the URL to uniquely identify a resource on the internet. We talked about HTTP. This is a set of rules to communicate between servers. The key thing here is that there's a request, and for every request, there's immediately one response, or not immediately, but like exactly one response, no more, no less. And every request has to be get if you're not modifying state, or post if you're modifying state. Exceptions do exist. Talked about the 3 parts of a website. HTML, it's how we make the website have features like links, forms, buttons. CSS makes it look nice with colors. JavaScript lets me execute code where? Inside the browser, like key thing, right? Okay. And the same origin policy stops different websites from interacting if they have different origins. Okay, that's it. Sorry for going over, and I'll see you on Wednesday. Okay.